Hey guys, today we're going to look at how to find the limit of absolute value functions. Now, just before we start that, we're going to go ahead and reevaluate our definition of an absolute value function. We know that the absolute value on a graph looks like this. It looks like a V. Now, if I were to write out the function would be a piecewise function because as you can tell from the left side, this is a line with a negative slope, which is, in this case, negative x. And then over here to the right of 0, it is a positive slope, so a positive x for when x is greater than 0, greater than or equal to 0. When we're finding the limits of absolute value functions, it's important to first write out the piecewise function. And the reason for that is because sometimes our piecewise functions could either be shifted, left, right, or up and down, or reflected, or whatever the case may be. So if we plug in a number x, it's automatically going to turn whatever is inside of the absolute value positive, which it may or may not be the correct answer. So just to verify, we're always going to write out the piecewise function. Now, if you were to look at the limit as x is approaching 0 from the left of our absolute value graph, we would use the equation from the piecewise function where x is less than 0, since that's to the left of 0. And if I were to find that limit, it would be 0. On the other side, we have the limit as x is approaching 0 from the right. So in this case, we would use x, which is from the piecewise function for when x is greater than or equal to 0. And we can also see that the limit is 0. When we are evaluating for absolute value function limits, we have to check that the left side and the right side are equal in order for our general limit to exist. So let's see if we can break down this absolute value function and write it out as a piecewise function. And I have some steps here for you to follow. The first one is to make the absolute value part, meaning whatever is inside of the absolute value, greater than or equal to 0. So I'm going to take that 2x plus 4 and make it greater than or equal to 0. And I use this equation, or rather inequality, to solve for x. And this is how we find out where your absolute value function would split. So we're going to go ahead and subtract the 4 to both sides. So 2x is greater than or equal to negative 4. Divide the 2. We get that x is greater than or equal to negative 2. So when we're writing our piecewise function, the absolute value of 2x plus 4 is going to equal to whatever was inside of the absolute value part, that's the positive side, for when x is greater than or equal to negative 2. And then for the left side, we put a negative and then put whatever was inside, 2x plus 4. You can choose to leave it like this. You can distribute the negative. It's really up to you. And then just switch the direction of your inequality. But in this case, instead of less than or equal to, it would just be less than, since negative 2 is already included in the first piece of my piecewise function. So now that I have my absolute value function translated as a piecewise function, we can go ahead and evaluate for these limits. If I were to find the limit as x is approaching negative 2 from the left, see that's where my function splits, and the left, I'm going to use the bottom part of my piecewise function. So what I'm going to do is I'm going to plug it in to the bottom part. So it'll be 2 times negative 2 plus 4. Which would give me negative on the outside, negative 4 plus 4, which in the end is just 0. Now, if I'm trying to evaluate for the limit as x is approaching positive 3 from the right of 2x plus 4, it doesn't matter that 3 is coming from the right or the left. Regardless, 3 is greater than negative 2. So we're going to use the top part of our piecewise function. So I'm going to go ahead and plug it into the top. So 2 times 3 plus 4, which when we work this out gives me 10. Let's look at some additional examples, and this is when it really becomes important for us to write out our piecewise functions for the absolute value portion of our function that we're trying to find the limit for. For this first one, I went ahead and wrote that limit for you. The piecewise function for you. The absolute value of x minus 1 is negative x minus 1 for when x is less than 1, and positive x minus 1 when x is greater than or equal to 0. And how I found that was exactly what we did in the previous slide. I just took the absolute value part and made it greater than or equal to 0 and solved for x. So for the positive x minus 1, that's when we use the x is greater than or equal to 1. And then for the negative, I went ahead and switched the inequality, and that's for when it's less than 1. So for this one, we have the limit as x is approaching 1 of the absolute value of x minus 1 over x minus 1. Notice that this is the general limit. So in order to show that the general limit exists, I have to show that the left side does in fact equal to the right side. So we would do the limit as x is approaching 1 from the left. Now when I look at my piecewise, 1 from the left is this top part here. So I'm going to write, which is negative x minus 1. And now I'm going to go ahead and plug in that 1. Oh, sorry, over x minus 1. My bad. The rest of the function. So when you look at this here, we can see that the x minus 1's cancel, and I'm left with this negative. So the limit as x is approaching 1 from the left is negative 1. Now I'm going to go ahead and find the limit as x is approaching 1 from the right of this particular function. Since this is from the right, I'm going to go ahead and use the positive x minus 1 to replace it in the absolute value part of my function. And remember that the absolute value part is over x minus 1, so I have to put it over x minus 1. Now we can see that the x minus 1's would cancel, and we're left with an answer of 1. From here, I have to compare the left side with the right side, and I notice that they're not the same value. So this means that the limit as x is approaching 1 of the absolute value of x minus 1 over x minus 1 does not exist. And the reason for this is because the limit as x is approaching 1 from the left of the absolute value of x minus 1 over x minus 1 does not equal the limit as x is approaching 1 from the right of the absolute value of x minus 1 over x minus 1. Moving on to the second example, we're going to go ahead and first write the piecewise function that would represent my absolute value. So we have the absolute value of x plus 6. And I'm going to take whatever is on the inside and make it greater than or equal to 0. From here, I would subtract the 6, and I get that x has to be greater than or equal to negative 6. This leads me to write my piecewise function. We have the positive x plus 6 for when x is greater than or equal to negative 6, and then we have the negative x plus 6 for when x, and then remember I switched the inequality, is less than negative 6. So this is my piecewise function that I'm going to be using to represent my absolute value function. Now I'm ready to evaluate for my limit. We have the limit as x is approaching negative 6 from the right of 2x plus 12 over, and now instead of writing the absolute value part, I'm going to look to see which piece I replace it with. Since this is for when x is approaching negative 6 from the right, I'm going to use that top part of my piecewise function, which is a positive x plus 6. Now remember, this is a one-sided limit. I don't have to test both sides because I'm only asked to find the limit as x is approaching negative 6 from the right. Now in the numerator, I can go ahead and factor out a 2. And that would give me 2 times x plus 6 over x plus 6. Here, my x plus 6's would cancel, and I end up with a limit of 2. Now, the reason we do this as well is because when we have this rational function with the absolute value, typically what happens is we have a problematic factor in the denominator, meaning that if I was to automatically just plug in that -6, for example, in this problem, I would end up getting 0 in the denominator. So that's why we're replacing it with the portion of the piecewise function so that we can cancel out that factor and indeed get the limit. Now let's practice with a few examples. So remember, I'm not concerned about the rest of the function quite yet. We are still just going to take the absolute value part of the limit that we're trying to evaluate for and write the piecewise. So in this case, the absolute value of x is equal to x, and there's nothing to solve for here, so that's just for when x is greater than or equal to 0, and negative x for when x is less than 0. And now I can go ahead and plug in the particular piece that I am looking for this particular limit. So we're going to go ahead and work this out. We have 1 over x minus 1 over, now this is as x is approaching 0 from the left. So since this is from the left, that x is less than 0, I'm going to go ahead and replace that denominator, which has the absolute value, with negative x. Because we have this negative over negative and then times another negative, we end up with 1 over x plus 1 over x, which if we add these together, it gives me 2 over x because it's over a common denominator. Now that I've worked it out, I'm ready to plug in my value. So we're looking for the limit as x is approaching 0 from the left of 2 over x. And if I plug in 0 into the denominator, I still get 0 in the denominator, meaning that limit does not exist. Moving on to b, the absolute value part is still just absolute value of x, so we're going to use the same piecewise function that we wrote earlier. And now I'm just going to go ahead and replace that absolute value with the correct part of that piecewise. So we have x over x and then minus, and then since this is as x is approaching 0 from the left, I have to plug in negative x. So this would be minus x, which of course a negative with another negative becomes positive, and I end up with the function x over 2x. So now just to reiterate, we have the limit as x is approaching 0 from the left of x over 2x. And these x's would end up canceling, and I end up with the constant 1 over 2, which would be my answer. Moving on to this next one, we have the absolute value of x minus 7 in the denominator. So I'm going to go ahead and write that piecewise function. We have positive x minus 7. And remember that we take that x minus 7 and we make it greater than or equal to 0. You would have to add the 7 to both sides, leaving us with x is greater than or equal to 7. So we use x minus 7 for when x is greater than or equal to 7. Then of course we got to switch it, so this is negative x minus 7, and we flip the inequality and not include the 7. So now that I have that piecewise function, we're ready to evaluate for this limit. This is the limit as x is approaching 7 from the right, so I'm going to use that top part of my piecewise function. So we have the limit as x is approaching 7 from the right of 7 minus x over x minus 7. Now 7 minus x and x over 7 look pretty much identical, except for the fact that they're completely different signs. The 7 is positive in the numerator where it's negative in the denominator, and the x is negative in the numerator where it's positive in the denominator. So because my goal here is to factor out that, or rather to cancel out that x minus 7, what I could do in the numerator is I could factor out a negative. And by doing so, that's going to change the signs of everything in the numerator, making it negative 7 plus x, which could be rewritten as x minus 7. And it is over x minus 7. And now that factor cancels out, and we are left with our solution of negative 1. For this last one here, we have the absolute value of 1 minus x in the denominator, so I'm going to go ahead and write that piecewise function. Remember that we take 1 minus x and make it greater than or equal to 0. If I were to subtract the 1, I get negative x is greater than or equal to negative 1. And then you would have to divide negative 1 in order to get the x by itself. And we get x. Now because I divided by a negative and this is an inequality, that switches your sign. So this is for when x is actually less than or equal to 1. Now what does that mean about the rest of my piecewise function? The first one that we get is always for the positive side. So this is for when 1 minus x squared, and we got the inequality for when x is less than or equal to 1. And we follow the same steps here. The second part of my piecewise function is when it's negative, 1 minus x squared. And then we do the same thing we did before. We switch the direction of the inequality. So now this will be for when x is greater than 1. Now that I have my piecewise, I'm ready to evaluate. So we have here the limit as x is approaching 1 from the right of 1 minus x squared over, and instead of the absolute value of 1 minus x, since this is from the right, I have to use the bottom one, which is negative 1 minus x squared. I'm sorry, why did I write squared? 1 minus x, not squared. Let me fix that. Now I switch colors. Don't know how I did that. Okay. Now that we have this worked out, okay, if you notice in the numerator, this is a difference of squares. 1 is a perfect square, x squared is a perfect square, and it's subtraction, so a difference. So for the numerator, we can factor that to be 1 minus x, 1 plus x, and it's all over negative 1 minus x. My 1 minus x's cancel out, and I'm left with 1 plus x over negative 1. Now I'm ready to plug in my x value, which is 1. And when I do that, I get 1 plus 1 over negative 1. 1 plus 1 is 2, divided by negative 1 is negative 2. Now we're just going to practice a little bit more just to make sure. For this first one, we have the limit as x is approaching negative 1 from the right of the absolute value of 9x plus 2. So what I'm going to do is I'm going to go ahead and rewrite this as my piecewise function. So remember, you take that 9x plus 2 and make it greater than or equal to 0. Subtract 2 to both sides. We get 9x is greater than or equal to negative 2. And then divide by 9, we get x is greater than or equal to negative 2 over 9. So my piecewise function for 9x, for the absolute value of 9x plus 2, would be positive 9x plus 2 for when x is greater than or equal to negative 2 over 9, and negative 9x plus 2 for when x is less than negative 2 over 9. Now my limit here is for when x is approaching negative 1 from the right. Now negative 1 is not where my absolute value function splits in the piecewise. So we just have to check which side does it refer to. If it's negative 1 is less than negative 2 over 9. So I'm going to plug it in to that bottom part of my piecewise. Therefore, the limit as x is approaching negative 1 from the right, I'm plugging it into the bottom, so it would be negative 9x plus 2 would equal to, and now I go ahead and I plug in negative 1. When I do that, I get negative on the outside. 9 times negative 1 is negative 9 plus 2. This would then give me negative times negative 7, which leaves me with my answer of 7. Moving on to b, we're going to go ahead and take that negative 1 minus x and write the piecewise. So we have negative 1 minus x is greater than or equal to 0. I'm going to add 1 to both sides, so negative x is greater than or equal to 1. And then we're dividing by a negative, which would switch the sign of your inequality. So we're going to use, for my piecewise, negative x minus 1. Oh, I wrote the wrong order. Sorry, guys. I am making mistakes all over the place. Okay. So negative 1 minus x for when x is less than or equal to negative 1. And then negative all of negative 1 minus x for when x is greater than negative 1. And now I'm going to evaluate for my limit. It says the limit as x is approaching 3 from the left. Now it doesn't matter that it's approaching 3 from the left. 3 is greater than negative 1. So because it's greater than, we're going to have to use the bottom part of my piecewise function, which is the negative times negative 1 minus x. And now I'm ready to plug in that 3. And when I do so, I get negative, parentheses, negative 1 minus 3. Negative 1 minus 3 is negative 4. And then a negative times negative 4 would give me a positive 4 as my answer. For C, we're trying to find the limit as x is approaching 7 from the right of negative 5x minus 9. Again, just like the other ones, I'm going to go ahead and start working out to write my piecewise. So negative 5x minus 9 is greater than or equal to 0. Add 9 to both sides, we get negative 5x is greater than or equal to 9. And then finally divide by negative 5. So we would get x is less than or equal to negative 9 over 5. Remember, since I divided by a negative, it switches my inequality sign. So now I'm ready to write my piecewise that represents this absolute value function, which would be negative 5x minus 9 for when x is less than or equal to negative 9 over 5, and then negative all of negative 5x minus 9 for when x is greater than 9 over 5. Now we're trying to figure out what is the limit as x is approaching 7 from the right. Again, it does not matter that I'm trying to find the limit as x is approaching 7 from the right, because 7, no matter what, is greater than negative 9 over 5. So I'm going to plug it into the bottom part of my piecewise. So what I'm looking for here is the limit as x is approaching 7 from the right of negative 5x minus 9. Now I'm ready to plug in my 7. I have negative times, now negative 5 times 7 is negative 35, and then minus 9 is negative 44. And negative times a negative will give me a positive 44. Last one here, we're going to go ahead and take that absolute value function and create my piecewise. Remember, we take the inside, we make it greater than or equal to 0. If I subtract the 1 to both sides, I get 4x is greater than or equal to negative 1. And then divide the 4, we get x is greater than or equal to negative 1 over 4. Therefore, my piecewise function is going to be 1 plus 4x for when x is greater than or equal to negative 1 over 4, and negative 1 plus 4x for when x is less than negative 1 over 4. Now I'm ready to evaluate for my limit. We have the limit as x is approaching negative 8 from the left. Now because it's approaching negative 8 is less than negative 1 over 4, so we're going to use the bottom part of my piecewise, which would be negative 1 plus 4x. And so now I'm ready to plug in that negative 8. And when you do so, you'll get negative, and then we have 1 plus 4 times negative 8, which is negative 32. 1 minus 32 is negative 31. And then a negative times a negative gives me a positive 31. And that's it. That's finding limits of absolute value functions.